In this question, the sliding velocity of the hydraulic actuator is given as 0.7. So to do the velocity diagram, we will choose a point on the hydraulic actuator that the shaft slides with respect to. So C prime, let's say C prime, which is a point on the hydraulic actuator. Now this C prime is going to rotate with respect towards A. So C prime with respect to A, the velocity is going to be perpendicular to the line CA. So I will transfer this line to the place I'm going to draw my velocity diagram. Okay. So I'll choose any point on this line and say that C should be there. So if I choose this point, say, okay, C prime should be here, then I'm saying C itself is sliding with respect to what? C prime, that it will pass through this point. So what I'm doing is I don't know the magnitude of C prime because I don't know the fixed point or the velocity A and E location. Right, so I'm just choosing any point for C prime, but I know obviously C is going to slide with respect to what? C prime, and the velocity is 0.7. So I'm using a scale, say 2 centimeters is equivalent to what? 0.7. That is to say 1 cm is equal to what? 0.35. So at C prime, I'll draw the velocity of C with respect to C prime, and that should be along this path through what? C prime. So I just have to transfer that. So I'll measure 2 centimeters and say that is C. So C is here. Now D relative C is going to be perpendicular to the line BCD. So I'll draw the perpendicular line and then transfer it here. Right. I mean, D with respect to C is a line like this, and on this line, B2 will be on it. Now I realize D is on top of what? C. So D will be somewhere here, and B will be below what? C. So the next thing is to find D with respect to what? E. Right. So D with respect to E is also going to be perpendicular to the line joining D and E, which is the same as from here to here. So we just need a perpendicular line to this. So since I don't know where A and E is, I just drew the line D with respect to E at any arbitrary point. So I will label this as B prime, D prime, sorry. So this is not the actual D, this is D prime. Now I'll measure from here to here, which is from here to here is 16 centimeters. That is 17 centimeters. So CD prime is 2.7 centimeters. So what will CB prime be? But we know CD prime is equivalent to CD, and CB prime is equivalent to CB. So CD is equal to 2.3, so CB is equal to 2.3, and CD rather, and CB is equal to 1.5. So if CB, if 2.7 is equal to CD prime 2.7 is equal to CD, which is 2.3, then how much of that will be 1.5? So x will be equal to 2.7 over 2.3 times 1.5. So x will be equal to 2.7 over 2.3. That will be 2.7 on 2.3 times 1.5. 1.8. So from C we measure 1.8, which is somewhere here. I mean, this is where, or this point, this is where B prime will be, and B with respect to A is going to be perpendicular to the line AB. So we will transfer that also. All right, so we will extend this line and then extend this line. All right, so they are meeting at this point, right? So where they meet, we join C to the meeting point. So I join from C to the meeting point. And I will extend the C prime's line. So where it cuts the C's line is where point AE should be, right? Then after finding the point AE, I'll draw a parallel line to this over here, and then a parallel line of this over here. So we have that. So this should be our actual D. And then it should be for B. So where B touches this line will be B, and where D will be. So you have your C here, D here, B here, A and E here.